I'll get like a 3, 7.
2
All
to
right.
negative 6 is negative 8.
Nah, you're good. I had a 31, bro. You're good.
It's how many you doing this for?
You're not going back. Negative. You're going back.
So it doesn't matter which point you pick, if I do A to C. A to C is 3, negative 7. And then if I do A to B,
You get 4 positive stuff. No, you have
it's negative 8, negative 2. So when I set up my
What'd you get, Jake?
determinant,
I didn't see that.
negative
You had
6 minus 56, so I get negative 62.
Thank you.
And make that
Thank
plus.
you.
Divide by
Thank
2.
you.
How'd you get I forgot to add. I forgot to add the negative.
Now,
3.
That was easy, like what, 2 points?
if
I
we
think I didn't turn it in.
get our notes out
I think
now,
that. I know you saw it.
we are ready for problem 33. Now, the last time we were together,
Hey,
you guys,
man.
you guys, this is incredibly disrespectful. I know you don't mean to be that way, but you're working. And you're in control of your own actions. Okay, so last time we were together, we talked about a whole bunch of, like, big ideas. And now I'm gonna throw one more at you. I think this is the last one of the big ideas. And what I mean by big ideas is, we talked about when you arrange things in a circle, it's 1 less factorial, right? We talked about if you make a necklace or a bracelet or a keychain, you have to divide by 2 because you can actually view that from 2 different sides and not change anything. It looks different, but you're not changing anything. We talked about when you have repeated items, you have to divide by the reduced factorial. All that stuff that we talked about, it's a lot. You're going to have to spend some time digesting all of it. Today I'm going to introduce one more idea, and it is what we call bundling. So what I mean by that is look at number 33. How many ways can 6 couples be arranged in a row if each couple must sit together? Now, if I just said 6 couples are going to the movies, how many ways can they be seated? You would say, no, you would say 12 factorial because there's 12 people, right? But I'm telling you now that if I go to the movies with Sam and I are going to sit next to each other.
Oh, yeah, for sure.
Right? And if you two go, you're sitting next to each other. We're going as couples.
That's cute.
All right? Now, that means if I'm going with Sam, someone has tied a string around us and we can't be separated. So wherever Sam sits, I'm gonna sit. So it starts with 6 factorial. That's exactly right, Joe, because there are 6 little bundles of people. All right, so each couple is tied together. So there are 6 of those. But, yes, Patton.
Why is there an exclamation point? That's factorial.
Okay, you need to watch a video, honey, you are. Okay, so those,
To be fair, he did miss half classes.
you missed most of them. So those 6 people, those 6 are not people, but 6 bundles tied together, groups, can be arranged 6 factorial ways. But, remember when I tied a string around Sam and I? It could be like this that I tied it around, or it could be like me over here and tied it around. So within that bundle, the Sam Mrs. Ford bundle, that could be done 2 factorial ways. That individual bundle can be arranged 2 of us, 2 factorial. What about this bundle? Another 2 factorial.
That's a good one.
And another 2, another 2, and another 2. So 1, 2, and another 2. So each bundle, okay, this is the number of bundles. Okay? Then you gotta multiply by each bundle factorial. So your answer, save yourself some time. 2 factorial is just 2,
Yeah.
so you don't need to type in the factorial. So 6 factorial times 2, 6 times. So the answer is 46,080. So there are 46,080 ways that they could go to the movies and be seated together. Yep. Okay, so there's 6 bundles of people, 6 factorial. But each individual bundle can be rearranged, right? And since there's only 2 people in the bundle, it would be 2 factorial. If there were 3 people in the bundle, it would be 3 factorial. All right, let's look at number 34 because it will help. I have 7 algebra books, and they're all the same. I have 4 geometry books, and they are different. And I have 3 trig books, and they are all the same. The question is, how many ways can I arrange these books in a row? So I'm just going to take this pile of books and put them in a row. How many books are there?
14.
So I'm going to start with 14 factorial.
Over 7 factorial.
Over 7 factorial, 3 factorial. Why am I dividing by 7 and 3? Because those books are identical. And remember our words like Mississippi, we had duplicate letters. What did we do with them? We divided by them. These are duplicate books. I'm dividing by them. Now let's make sure we can type that in. It's 14 factorial divided by 7 factorial. Don't cancel, kids, there's no shortcut. Divided by 3 factorial. Make sure that you are divided by, there's no times. So it's this, divided by this, divided by this. And the answer is 2,882,880.
So you have to do it separately, you can't just do it all in one thing?
What do you mean?
Like, so I can't just do 14 factorial divided by 7 factorial, 3 factorial? I have to do 14 factorial divided by 7, and then divide again?
Yeah,
Oh.
yeah. So you can do it all at once, but it's divided by. You have to hit the divided by twice, all right? Because those books are all different. It's like different letters. They're different letters. Oh, I see.
It's just about
H and
reading.
J. Okay, yeah. Yeah, I gotta read. Okay, letter B. I'm going to do the same problem, but now I want to be organized. So the books of each kind are going to be kept together. So in other words, I'm going to tie a string around these. I'm going to tie a string around these and tie a string around these. I am no longer arranging 14 things. I am now arranging 3. So I start with 3 factorial. Now, when I tied a string around 7 books, within that bundle, it can be arranged 7 factorial ways. Now hang on, I know what some of you are thinking, and you're right, but just hang on. This bundle can be arranged 4 factorial ways, and that bundle can be arranged 3 factorial ways. But these are still the same. So I still gotta divide by 7 factorial and 3 factorial. Now these will cancel. You are definitely allowed to cancel those. They're the same. So your answer would just be 3 factorial times 4 factorial, which is
That's for B.
144. That's for B. This is problem B. So again, this problem kind of includes a couple of different things. Bundle your items. If they have to stay together, tie a string around them. I have 3 things to arrange. But when I tied the string, just think of those those seven can be arranged 7 factorial ways. These 4 factorial ways, these 3 factorial ways. But since these are identical, I have to divide them out because they're duplicates. All right, let's look at C. C says I have the same books, so I have 7 algebra identical, I have 4 geometry different, and I have 3 trig identical. Okay? This time, when I arrange them, I only need to keep the algebra ones together. So there is a string tied around those books. So they don't function like 7 anymore, they function like 1.
Oh.
These 4, however, are separate. They are separate books.
Yeah.
So here's 1, here's 4, that makes 5.
And there's 8.
Here's 3, that makes 8. So I'm gonna start with 8 factorial. Anything I bundled, which is just these, I have to factorial. Because that bundle can be arranged, 7 things, 7 factorial ways. But those are still the same, and those are still the same. So I always divide by identical things, no matter what else is going in the problem. Yesterday, does it have a clasp or not? I don't know, and it doesn't matter if the beads are the same, you divide them out.
So why did we skip geometry?
We didn't skip geometry.
These are different.
They're different books.
Oh, that's right. Oh, I see. Okay.
And
I
I
see.
don't
Yeah,
divide by things that are different.
Yes.
I only divide by things that are the same.
You're right about that.
So that answer should be,
Bless you.
Thank you.
Oh, bless you.
So it's really just 8 factorial divided by 3 factorial.
yep, so it's 6720. All right, we're almost done with this. We've got all the big ideas down. Now we just need to look at how do we calculate them by hand? So, back in, when I was your age, we didn't have calculators, so we had to do it by hand. Now, you don't really ever have to do it by hand unless there's no numbers, it's just letters. Then your calculator won't do it, and you have to be able to simplify by hand. So, I'm gonna give you the formulas right now for simplifying a permutation problem and a combination problem. They are very similar, but they are different. So, here we go. This right here, if I were gonna do it by hand, you can
Yes.
type it in and get an answer. But if I were gonna do it by hand, it would be 10 factorial,
Okay.
that makes sense,
Yeah.
divided by 7 factorial. Now, where in the world do you think
10 minus 3.
10 minus 3, that's exactly right.
Okay.
So in general, for a P problem, you're gonna have n factorial over
N
n
minus
minus r
Factorial.
factorial.
Okay, got you.
That's your general formula. Now, if we need to simplify this by hand, it's very easy. What does 10 factorial mean? 10,
10,
9,
9,
8, oh, da, 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 da. Now, look what's gonna happen. 10, 9, 8, 7, da, 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 da,
Yeah.
over 7, da, 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 da.
So they cancel
So
out.
it's just
So
10, 9, 8.
all of that
Yes.
is gonna
So
cancel.
it's just
720. 720. Nope, I got it.
End up
Sit down, little boy.
with 10 times 9 times
I
8.
said 720.
720.
It's 720.
No, 700.
Sit down, though.
So we don't cancel in the factorial form, but once you start multiplying it out, you can cancel whatever cancels. Alright? Now, let's look at the C problem, and tell me again, what's the difference between a P and a C?
Nothing.
Oh, yeah, there's a
Oh, wait,
big
I meant,
difference.
Yeah, go ahead. What's the difference?
It's like one, that you're figuring out for one thing, and then it's like 2 separate things, and then it's like one of the same group, right? right?
So it's whether
You just
the
come
order of choice matters. These both involve 10 people choosing 3. Here, it would be if I were picking a president, vice president, and treasurer. Order matters.
Lanyard check.
Your president, your vice president, and treasurer. Order matters.
We get a lanyard check.
Here, I would be picking like a leadership committee. Okay, of 4 or something, or 3 actually, a leadership committee of 3. Order doesn't matter. This
Phone check.
is 10 factorial
Phone check.
over 7 factorial, just like before, but also over 3 factorial.
Oh, so it's the same
So
thing.
the combination
But just monthly.
is 10 factorial.
ID check.
You do the minus, and you keep the R. So that formula would be n factorial
Airline check.
and minus R
Here, what?
factorial.
Not you.
Just R.
Dear God.
So the combination will always be smaller than the permutation. Because if order doesn't matter, there are fewer ways to choose. Alright, so what's this gonna equal? Let's do the same thing we did before.
It's gonna be
10, 9, 8, 7.
720 divided by 6. 720 divided by 6.
So
Which is
everything from 7 on is gonna
which is
cancel,
11.
right?
What's it?
The 3 goes into the 9, the 2 goes into the 4, so 10 times 3 times 4, 120. If you
Oh,
said
I was
120,
I was
you were right.
Wait,
Meant
you
120.
can just plug
What do
in
you mean,
like
something
that
else?
as your calculator. Or
Yes,
you can't do that.
you can throw in.
Not if we're doing it by hand.
No.
So, yes, Caitlin, your calculator will do this problem. If you are being asked to do it by hand, then this is doing it by hand. Oh, don't hold your head, it's okay. You can do it.
It's not okay.
We believe in you.
Alright, 9-1 homework will be due on Wednesday.
Can we do a phone check?
Alright,
No, lanyard ID. There's someone in here.
can you guys
Just worry about your
just
I'm not
be
part of
nice
this.
to one another?
Garvey, where's your ID? Hey, ID check, Garvey. Cat. No, look at his ID.
Are you guys like, bro?
No, it's not on there.
Sorry, Dave, can you tug on your,
Yeah, I'm talking
no,
about.
tug on like just that.
What do you mean? Mine's good. I'm good.
Alright, here we go.
Oh, there it
Mind
is.
you-
Mine's good.
Just like do math.
Yeah, I know.
Guys, can we just stop? Can we just
Oh,
listen to
Aiden,
this?
you were the one
Alright.
lobbying
No,
for a phone.
just made Aiden puts glasses on and thinks he's him.
Yeah, those are.
Is 9-1 due on Wednesday?
Class about political economics of the world.
Alright, I've only written 4 infractions today, and I'm about ready to write some for disrespect, and you'll be the first one. So I need you to focus and pay attention, be respectful of me and respectful of each other. That means no more insults about anything, alright? No more. We like each other. Okay. For a moment, I want you to just kind of sit back and watch this. Because I'm not asking you, I want you to write down the answers that you get, but I am going to expand x plus y to the first power. That's just x plus y. Everybody knows that. And then I'm gonna expand x plus y to the second power. That means it would be a FOIL. And that would be, you don't have to FOIL it out, just write down what I get. That would be this right here.
Oh,
That's what I get if I FOIL. Now I'm gonna expand x plus y cubed. Alright, and that would basically be this times this, right? 3 of them?
Yeah.
So I know that's x cubed. Go ahead and just write this down. I'm not asking you to memorize it. I'm not even asking you to work it out. I just want you to observe something. Alright, and then we're gonna do x plus y to the 4th.
Wait, Miss Ford, have you actually memorized like all
No.
of that? Oh, okay.
No.
No.
What, you think?
I am a terrible memorizer. Remember, I have a 66-year-old brain that's had 2.5 years of chemotherapy. There is no way I memorize very little. There is a trick here. In a moment, you are going to do x plus y to the 5th, okay? And you're gonna use the trick, but I want you to observe the trick.
Oh.
So I want you to kind of look at what's going on here, what do you notice? And then let's see how much of the answer we can build. How much of it can we build? So, tell me what you have observed.
Oh, I already got it.
Oh, I got it.
Okay, so Patton thinks we're gonna start with an x to the 5th. And maybe, let's go out on a limb, what are we gonna end with?
Y to the fifth.
There you go.
And
So we got our start and end figured out.
Your next number is always the exponent.
Then it's 5x squared
Plus 5.
y.
So this one's gonna be 5x squared y,
No, 5 x to 4. You gotta go down one. It's 4.
5x to the
4.
4.
Or
And
4.
then y always stays 1.
So does that work okay, everybody?
Yeah.
Plus.
Alright, thoughts?
Plus 8.
Plus 8?
No.
Because it's doubling.
Alright, well, let's just go ahead. 8 what?
8x.
No.
Just stop. Be nice. Leave him alone.
You got it, man.
What would
You got
be the letters here?
AX cubed.
Proud of you.
I don't know. I don't know. That's right, Ron.
Yeah.
Y cubed?
No?
No, y squared. Squared. X
Yeah. Because I don't know if you've noticed this or not, but like in this row, the exponents all add up to 4. So in this row, the exponents are all gonna add up to 5. So whatever this is, it's gonna be x squared y cubed,
It's gonna be 5.
and this is gonna be 5 x y to the 4th. Would you agree with that? So I'm missing a number. You can guess on that, Ronan?
That'd be 5.
I have a 5 there.
4. Or 8.
8, number 8?
Where'd you get 8?
Okay. I don't know. I figured out where anybody got 8. But let's look at what we've got so far. Other than the 8s, it's perfect. So does everybody see what's happening to the variables?
Yes.
X to the 5th, x to the 4th, cubed, squared, 1, no x's. And then y's are the same thing?
Yeah, backwards.
Okay, everybody good with that? We are in agreement, I think, across the board, that we're starting with a, like this is a 1 x to the 5th, and ending with a 1 y to the 5th. And then the next term in, both ways, is whatever that power is. So since this was the 4th, that's a 4, this was a 3, this is gonna be a 5, and that's gonna be a 5, right?
Oh,
Are we in agreement? The only thing that's wrong about what you just did are the 8s. So we need to figure out what in the heck is happening
It's
with
7.
those. So,
It's
let me
16.
show you
7. I got it.
the trick.
A7.
Alright, let me show you the trick. If you look at the coefficients there, the first one is just 1 and 1. Okay, 1x, 1 y. Here, we have a 1x squared, a 1y squared, and a 2 in the middle. That 2 came from adding that 1 and 1. So my next row, this is gonna be a 3 and a 3. And my next row, that's gonna be a 4, a 6, and a 4. So the row you want, you're gonna have a 5, which you knew, 1 and 4, then 10, 10, there's your 5 again that you knew. So these are 10s.
What's that 8 again?
There's no 8.
I didn't say.
Someone said 8.
So if we wanted, we don't have room and I don't wanna do it, but if we wanted to do x plus y to the 6th,
X is
you know what the variables are already, right? You got that. And then the coefficients, the numbers, would be
15.
1, 6,
15.
15, 20,
Wait, what? Oh.
50, 14, 6, and 1. That triangle is called Pascal's triangle.
Oh, I've heard of that before.
Heard of what is Pascal? Yep. And I wish we had more time because I don't know if we will or not get to it, but the reason we're talking about this is because Pascal actually looked at this triangle, kind of wrote it down and studied it, because his friends, who were kind of bad people, gamblers and whatever, came to him and said, hey, Blaze, you're smart, help us beat the odds. So he did this for, like game theory. This is at the beginning of game theory. It's binomial probability, like a coin toss. And this can predict the probabilities for tossing a coin and getting a certain number of heads or whatever. I hope we get to that. All right, so we're not there yet. So what we're gonna do now is look at problem 2A. I'm gonna erase all this, but I'm gonna try to leave part of my triangle there. I'm gonna erase all this, and now we're gonna do problem 2A. This is going to be easy if you're paying attention. It's gonna be overwhelming if you're not. So please pay attention.
Oh, God.
I'm gonna get rid of this.
It's hard for Jake. Hey,
Alright, so my job is to expand x minus 2y to the fourth.
oh no.
I do not want to multiply out FOIL x minus 2y 4 times. That would take a very long time. So, I'm gonna remember that if I'm expanding to the fourth
The
power,
first one's extra 4.
I'm gonna use these numbers. Those are my numbers that I'm going to use. Look back in your notes. When we did x plus y to the fourth, weren't those our numbers?
Yeah.
Yeah, those are the numbers you use if you're going to the fourth power. What?
Do you have to memorize the triangle or
You have to know how to build it,
Okay.
which it's easy. We just
Yeah.
add.
Yeah.
Right, each row starts and ends with a 1, and then the middle numbers are just found by adding.
Wait, how'd you get the threes you added 2 and 1?
Mhm.
Yeah.
Just making sure I'm on the same page.
No, you're on the same page.
Yeah.
Okay,
You're welcome.
Same chapter.
all right, you ready?
Yep.
So I am gonna write down 1, 4, 6, 4, 1. This is called expansion. So use the page, guys. Use the page. You're gonna have a lot of stuff to stick in here, and it gets confusing if it's smushed. Spread it out. Why am I using the fourth row? Because I'm expanding to the fourth power. If that were a 5, I'd be using the fifth row. All right? Now, in our last problem, all of our terms had an x and a y. And that was because we were expanding x plus y.
Yep.
Now, all of my terms are going to have an x and a negative 2y. So I'm gonna write down x and negative 2y. That's not a minus, that's a negative. X and negative 2y. I'm gonna write it down next to each one of my numbers. And then I'm gonna take attendance, because I forgot.
Oh, wow. Surprised they ever called you that.
Yeah, sometimes they do call, we're missing Jaden
I know what kind of joke already.
and Reyes.
Oh wow.
What, where is it?
Yeah,
Oh, yeah, they're
Lockhart.
Lock, yeah.
I think there's like a leak in your ceiling.
Well,
There's like a little hole up there.
is water coming down?
I don't know. I felt some water on my back.
Probably been the noise.
Let me know if water comes down.
There is 0 water in my water bottle.
There should be a little hole right there.
There
the top.
There is still
Everybody
0
ready?
water in my water bottle.
Now, whatever the two parts of the problem are, and these are all gonna be binomials, there'll be 2 things in there. Whatever they are, each number gets them. When we expand to the fourth power. The power on X will be 4. And then it counts down. When it gets to the end, it's a 0. And that's why the last term didn't have an X in it. Because X to the 0 is 1. And then the Y's, remember, did the same thing from the other end. And that's why there wasn't a Y in the first term, because it was to the 0.
So actually 14.
Now, put big old plus signs in between each term,
Why do we just cross out some?
because it's to the 0
Oh,
power.
yeah.
And bonus, anything to the 0 power is 1. So now we simplify. What do we get here? What is this?
That's
X
X
to
X to
the
the
fourth.
4th. Done.
4x to the third.
Watch it.
4x to the
Four
third
X.
This
minus.
one
No,
is
eight.
minus
8x.
8
Oh.
x cubed y. Remember, that is not a minus. That is a negative. You are multiplying 4 times negative 2. So it's negative 8.
Minus
X
12.
to the cubed y.
Minus 12x
24.
squared.
24.
No, the next one will be plus 24 x squared y squared.
Did you just
Remember,
read the 2?
everything gets squared,
Oh.
including the negative 2.
So,
So this actually becomes a 4 times 6, 24.
There's no exponent on the negative 2 or negative 2.
Now what about this one? Be careful.
Plus 8 minus
That
8x.
is a negative 8
8x.
times 4.
negative 32.
Negative 32 xy cubed. And then what's on the end?
Minus 2y.
No.
Minus.
Plus
Oh my
16 y to the 4th.
I'm checked out.
The parentheses are essential. And when you put a power on the parentheses, everything gets powered.
Actually. But why is it? Oh, wait, never mind.
Now, with your partner, I want you to take a stab at B. With your partner, do what we just did, but do it for problem B.
4 times negative 8.
Yeah.
2x.
1 16.
3y.
I just forgot about that.
Hey, Jay, now, you and your partner should be started. What is the first thing you're writing
The
down?
number
The
is
pyramid.
The numbers.
1, 3, 3,
And the numbers are gonna come from the third row. So you're writing down 1, 3, 3, 1.
Wait, you get the work. Is that from the power?
3.
Power.
Yeah.
2x.
See, when you pay attention,
Like,
it
dude.
helps.
I thought it was okay.
Now,
Write down the number first.
next to each of the numbers, what are you gonna write?
2x.
2x and then plus 3y.
2x and
No, it's just 2x.
3y.
Well,
No, it's not.
Next to
You
all
know
of them.
No, I didn't.
No, you know it.
Put them in parentheses. They are being multiplied. 2x and 3y are being multiplied. Now what do we do?
Put the exponents.
Put on the exponents, remembering that on the x, on the first one, it's gonna start with 3. And then go down to 2, 1, and 0. Anything to the 0 is 1, so you can cross that out. You're not gonna have an x at the end. And then the y's, you're doing the same thing, and you can get rid of that first y. Now, these are individual, separate terms. Everything here is getting multiplied. So we have 1 times what?
2x to the third.
So 8x cubed.
What do you think?
2 to the
Okay.
third.
Got it.
So easy, yeah.
You got it. You waiting for that?
12x
Now,
squared.
36x
the
squared.
next one will indeed be 36
X squared.
Oh, I didn't see the
squared y.
3.
We do it.
Why is it 36?
Because
Because you have a 3, a
Times
4,
and then
and a 3.
Alright,
That makes 36.
Next
Alright,
one.
then we got the what?
54.
54 x y
9,
squared.
2,
18
3.
times 3.
That's
54.
54. XY squared.
Right there, come back. Right here, come back.
And on the end,
27y cubed.
27y cubed. That is exactly right.
Might be him.
We had a small. We had mid.
that makes sense.
End on a high.
No. Okay, we'll have another high. Here comes another high. Now, look at problem 3. Oh, yeah, Elijah looks at the problem, he says, 10? What are you talking about, 10? Why is that alarming?
Because it's a big number. Big, right?
I would have to keep my pyramid going a long way. So, good
There's a
for
catch.
you,
There's a
there's
catch.
a shortcut.
There is a catch.
Okay, there's a
Airball.
shortcut.
1, 2, 3, 4.
So, here's what I would like for you to do. Very quickly on your calculator, I want you to type in
I swear.
5C5, 5C4. Don't add them, just figure out what each one is individually and tell me what the numbers are. So type those into your calculator. First one, 1, okay? Type them in.
Yeah, you got it.
You got it.
Yeah.
You got it. Probability.
It's like 15.
1 and 3.
Well, I'm looking at 15. What's 5C2?
10.
And again?
5.
And then 1. Yeah, thank you. You're good now. You're good.
Have we seen those numbers before?
Right there. Right there.
The fifth row of the triangle
the last.
is the 5C numbers. So we start with 5C5, 5C4, and so on. So the 10th row of the triangle would be 10C10,
Oh my god.
10C9,
She's not on your iPad.
10C8, 10C7, 10C6, 10C6, and so on, until it got down to 10C0.
I don't even have space in the paper to do this.
You don't need to write them all down, because luckily, we don't want the whole thing, we only want the fourth term. So 1, 2, 3, there you go. There's the number you're going to use. That is the fourth number in the 10th row. What is it, Ronan?
120.
120. So instead of having to write down all of the numbers like we did before, we're only gonna write down the 120. Next to the 120, however, there will be an X and a Y.
X to the 6, Y to the 4.
Is that good?
Yep.
And then, be careful, it's not 6 and 4X.
It's 10
7 and 3.
Here it would be 10 to the, or it would be X to the 10th,
Oh, so it's
9, 8,
7
7.
and 3.
The fourth term is actually X to the 7,
Why to the third?
Y to the 3rd. And there's your answer. 120, X to the 7, Y to the 3rd.
How do you know to
Like
use
this
the
up, up.
fourth
We got one more,
term?
Brody. We got one more.
Oh.
Yeah.
Alright. Hold on, guys. Hold on to them.
Don't worry, 'cause I got you.
One more.
Sorry, let's see how it's
Here we
Wow,
go.
what, did you just hear that?
Joe, don't you ever do that again.
We want,
Obviously, someone else needs that.
we want the third term. So, it's to the 7th.
7 and 5.
So 7C7 will be the first
7
term.
C5.
7C6, 7C5. That's the one we want.
21.
21. So we're gonna start with 21.
2X to
Next to the 21, 2x negative y. That is not a subtraction. It's 2x times negative y. In the first term, the power on the x would be 7. Then it would be 6. and the one I want is 5.
Oh, okay, that
I
makes sense.
counted down, just like I did when I did the whole row, 7, 6, 5, 4, all the way down. If that's a 5, this is a 2, because they gotta add up to 70.
672, x to the fifth, y to the second.
So now, I'm gonna multiply 21
Okay, okay.
times 2 to the 5th, so he's right, 672,
Whoa,
x to the 5th, y
I'm
squared.
glad you can do it.
What happened to the negative?
Oh, yeah, can't do like this.
It got canceled out. It got canceled.
When does yours start?
Look at the wheels.
But